Hi dear friends, how are you? After long days of getting the chance to see you. Very nice to see you dear friends. I am Selva Rasu, your physics teacher. I hope all are fit and fine in your home. Dear friends, we know that due to the corona pandemic, the whole country has lockdown. The country is struggling with schools, teachers, and lack of education. Most of the schools of the country have started online classes. Dear students, you must take advantage of this opportunity. Our school management also started this class, smart class, to continue our study. It is easy to make the connection with you all, and it will help us to cover the syllabus and to maintain the flow of study. This connection is not limited to the class, but the session will be available for all. I will love to see your individual talents and strength. I recommend you take the practice in physics, especially units, formulae, diagram, definition, and explanation, other facts also. If you have any query, you can ask the WhatsApp group. Stay home, stay safe. Dear students, in 11th physics first chapter, we are going to discuss about the topic name is parallax method. What is the name of the topic? Parallax method. In this method, we are used to find the large distance, such as distance of a planet or what is it? Star from the Earth can be measured easily using by this method, parallax method. If you wanted to understand or know about this method, we can easily understand through one what is that diagram. Especially, let us consider or assume you are standing here. So while you are standing in this position, you are seeing, looking one object. This is, let us say, object O. What is this? This is an object. Okay. So in the first case, you should close your right eye. You should close your right eye and you should see this object through this left eye. In the first case, you should see this object through this left eye with close the right eye. Okay, this is the first case. And in the second case, you should close the left eye and you should see that object through this right eye. So while you are seeing at one time left eye, another time right eye, what will happen? We are able to see the position of the object will be changed. The position of the object will be changed. The changes of the position of an object, we can say apparent changes or apparent position of the object. Apparent, which means it's nothing but it is the changes. Okay, what is that? Changes. So, what is the apparent change in the position of the object? Position of the object with respect to the background. With respect to the background, when the object is seen from the two different positions. So, what are the here two different positions? At one position left eye, at another position right eye. So, while you are seeing the two different positions of the left eye and right eye, that object, what will happen? The position of the object will be changes. Okay. So here already we know that the distance between the left eye and what is that? Right eye. Okay. So while you are seeing through the object, seeing the object through the left eye, right eye, the position of the object will be changes. Already I told you that is the apparent change of an object. So while the position of the object changes with respect to you, which means your left eye and right eye. So what will happen? The apparent changes only we are saying that is the parallax. What is the parallax? Parallax is nothing but while we are seeing the two different positions, the object will be changes. The apparent changes of an object, we are saying parallax. Parallax. Okay. So now this position, the changes of position of the object create or makes the angle with the what is the two position left and right. What is that? That is said to be angle theta. This angle we call as a what is that? Parallax angle. Parallax angle. So parallax angle is nothing but the changes of position of the object makes the angle with this two position left eye and right eye. That is what is that? The angle is called as a parallax angle. Okay. So we know that the distance between left eye and right eye. Okay. So this is said to be what is it? Object. Oh, this is left eye and right eye. You know the distance between left eye and right eye. Let us say A, and the distance between L and O or R and O we don't know. Okay. So simply we give the name or let us assume this is the X. Okay. So if we wanna find out this parallax angle theta, what should we do? So here theta parallax angle theta equal to, so this is the base. Okay, this is the base. Just a minute. This is the base or opposite. Okay, opposite side. This is the what is that? Adjacent. So what will we get here? What is that? The first one is opposite divided by adjacent. So here A divided by X will come. Theta, the parallax angle, theta is equal to A divided by X will come. So if you wanna to find out the distance from object to this position or O to L or O to R, that is we call as X. So X equal to what will we get? A divided by theta will come. So this is the final or the distance between this position, which means left eye or right eye to object. Okay. So this same method we are using to find the determination of distance of moon from the earth. Okay. What is the next topic? Wait. Determination of distance of moon distance of determination of distance of moon determination of distance of what is that moon from the earth. So already we have discussed how to find. Already we have discussed how to find the parallax angle using by that position of the left eye and right eye. So I told you already x equal to what is that? B divided by theta will come. The same method similarly we are using in this case also. So let us assume this is the earth. So at the center of the earth or diameter of the earth, we can say, or let us indicate the letter C. And next we are assume or consider moon. So this is nothing but moon. Okay. Come to listen. This is the C. So in the previous case, we have discussed there are two questions. So one is the left height, another one is the right height, isn't it? So likewise, here also we are going to consider two questions or two persons. So one person, let us consider name of the person is A. Another question, the name of the person is B. Okay. So one example I want to give you, especially while we are traveling by the bus, if we look at the scenery through the windows, if any near object is there means what is that? If we observe the near object while we are traveling by the bus, it is moving very fast respect us or by the bus, respect the bus. At the same time, if we look at what is that? Far away from us object, if you look at far away from us any object, so it is moving very slow than the very nearest object. So listen carefully. While we are traveling by the bus, look at the scenery object. So we are considering two things. One is those things, those objects present nearby us, and those objects present far away from us. If a near object moving very fast with respect us, and the far away from us object moving very slow than what is it? Very slow than the what is the nearest object. Likewise, the same examples we should recall wherever what is that need for us. So here we should consider two objects. One is the earth, another one is the moon. So what is that? In the previous case, we have discussed, no? Likewise, there are two questions, left eye, right eye. Here also two persons, A and B. So in this case, a person standing in the position of A. Okay. So this person going to find the distance from the center of the earth to moon. If you wanted to find the center of the earth from the what is that? Earth to moon means is what is that? He should immediately cannot find out. So that's why what is that? It will take more time to find the distance of the moon from the earth. So he is slowly moving from A to B. It may take what is that 2 months, 3 months, or up to 6 months also. Why? Because if what is the distance will be less means automatically this person, the person A, is able to find out what is that very soon. But it's very huge distance, so that's why he is not able to find out within very short period. So that's why it will take more time to find the huge distance from the center of the earth to moon. Center of the earth to moon. So that's why we will what is that move from A to B. So at the beginning he is standing at the position A, then at the end after 6 months or after 5 months we don't know. So at the what is that finally he come and what is that standing at the position B. Okay. So now automatically here also the position of the moon will be changes. So what should we do here? We should what is that this moon will make the angle makes the angle with this what is that earth, that is said to be what is that theta. What is that theta? Okay. So in this case we don't know here also the distance between what is that M to A or M to B. Okay, but we know the distance or diameter of the earth. Okay, so especially the diameter of the earth, if you want to be saved, is 12,742 kilometers. This is the diameter of the earth. Diameter of the earth. Just a minute. 12,742 kilometers. We know the distance. or base of this earth, but we don't know the distance between M to A or A to B. So if you wanna find out the distance, what is the aim? Our aim is to find out the distance of moon from the earth. If you wanna find out means, what should we do? We should draw the two imaginary lines. So this is the one imaginary line. This is the another imaginary line. We can say this is the S1 and S2. So while we are drawing these two imaginary lines, automatically the two angle will be created here. So this is here angle theta 1 and here angle theta 2. Okay. Now, according by the properties of the angle, according by the properties of angle, properties of the angle, according to the properties of angle, exterior angle equal to interior angle. Interior angle. So here exterior angle is nothing but theta. Sorry, interior angle is nothing but theta, and exterior angle is nothing but theta 1 and theta 2. So exterior angle theta, just a minute. Interior angle theta equal to exterior angle theta 1 plus interior angle, what is that? Theta 2 will come. So again, one more time, I'll tell you, according to the properties of the angle, exterior angle equal to interior angle. So what is that? Here, exterior angle theta 1 plus theta 2 equal to theta, or otherwise, according to the above statement, we can write like this. So erase this. Exterior angle, okay, exterior angle equal to interior angle. Exterior angle theta 1 plus theta 2 interior angle theta. You can write like this. Okay. So according by this, we should find out the distance of the moon from the earth. Okay. So here angle theta equal to opposite or base. This is the base or opposite AB divided by what is the adjacent, or otherwise we can say this is the what is that? AM. Okay. So AB is equal to C, no? AB equal to C. Okay. So instead of AB, we can substitute C. C divided by 1 minus C, or otherwise directly you can write like this. So instead of C, write out AB itself because it is convenient for us. So that's why AB. So one thing we should note down. So this distance AM, which is almost equal to the what is that? AC. AM almost equal to the MC. So that's why instead of what is that AM, we can substitute here MC. Okay, we can substitute MC. Okay, or otherwise, what is that? If you want to be substitute there, that is base, instead of what is that? This AB, we can substitute C also. AB is equal to C. C divided by MC. Okay. So directly we can write theta equal to c divided by mc. So mc is nothing but, students, the distance from the center of the, over the distance of the moon from the earth. So that's why, what is that? We need, or our aim is to find the distance of the moon from the earth. So mc is nothing but, that is the distance of the moon from the earth. So mc equal to c divided by theta will come. So in the previous case, what did we write? X equal to b divided by theta. So instead of s, here mc coming. So mc equal to, there we used b, but here we used c divided by theta. So mc is nothing but distance of the moon from the earth. So we have to find. If you want to know about the distance of the moon from the earth, means if we use this formula, automatically we are able to find the answer. Known value substitute in the formula, easily we are able to find the answer. Okay, can you understand, dear students? Okay, so next we are going to discuss about the topic name is radar method. What is that? Radar. The word radar, already, what is it? You heard, you may get the chance to heard. Okay, so again, one more time we will discuss. What is the name of the topic? Radar method. Radar method. So in this topic, the word radar stands for radio detection and ranging. Radio detection and ranging. This is radar method. It stands for radio detection and ranging. Okay, so this is a method. It is used to measure the accurately distance of nearby planet such as Mars. But in the parallax method, it is used to find the large distance. Large distance, what is that? Such as distance of a planet or a star from the Earth. But in the radar method, especially, can be used to measure the, what is it? Accurately the distance of the nearby planet such as Mars. So in this method, radio waves are sent from the transmitter. Okay, so let us consider. Okay, let us consider one, what is it? Especially components, or otherwise, what is that? Radar. So this is the instrument. Okay, so you can draw like this. Okay, so if we take this, there are two components. So one is the transmitter. One is the transmitter. Another one is a receiver. What is the another one? Receiver. What is the working of transmitter? It will transmit the, especially that waves. Especially what waves? Radio waves. Okay, what is that? Radio waves, or otherwise electromagnetic waves. Okay, so it will be, what is that? Moving from one place to another place, or a transmitter. Okay, transmitter to some, what is that? It will what is travel for long distance. Okay, so here let us consider one object. This is the one object. Okay, this component will transmit the waves, electromagnetic waves. So while it is moving from one place to another place, In across, if any object will come means what will happen? So it will strike or hit on this object. For example, this wave is moving. Just a minute, wait. This is a transmitter. Wait. Conclusion. Okay. This is a diagram. Let's say this is a radio instrument. Okay. This is an object. Object. Okay. There are two components. One is the transmitter. Another one is a receiver. Another one is a receiver. Okay, receiver. What is the working of transmitter? Already told you. It will transmit the waves. Okay, it will transmit the waves. Already told you what is that? Especially it will transmit the radio waves. This is in the form of electromagnetic waves. And what is the working of receiver? So it will accept or receive that waves. So while the waves are moving from transmit, okay, so moving from here, so this transmitter transmit the waves. What happens after strike on this object? It will return back to the receiver. The receiver will accept the receiver will accept that waves, radio waves. So this arrow mark indicates the direction of the what is it? This waves. Arrow mark indicates the direction of the waves. So transmitter will transmit the waves, receiver accept the waves. This arrow mark indicates the direction of the waves. What will happen while this waves is what is that moving from one direction to another direction? If any object come and what is that come across this what is that waves? What will happen? It will strike. For example, if I want to say means while we are throwing any what is that one ball, cricket ball means towards the wall side, after strike on the wall again it is returned back towards us, isn't it? The same principle we can use here itself also. So what is that? When it is returned back, the receiver will accept the signal. Okay, so while it is moving or coming, what will happen? It will take some time. So while it is moving from this transmitter to on strike on this object, it will take the time 2 seconds. After strike these waves on this object, while it is returned back, it will take what is that? Some time. That's also we can say 2 seconds. So totally time is 4 seconds. The speed of this wave, which is equal to the speed of the light. We know that already the speed of the light c equal to 3 into 10 to the power of 8 meter per second. 3 into 10 to the power of 8 meter per second. Okay, which symbol indicates the speed of the light? Symbol c. Now our aim is to find out the distance. Okay, our aim is to find out the distance. Okay, between this what is that instrument? What is that? This radar and also this object. Distance. Okay, so already we know that formula. What is the speed formula? Okay, what is the which symbol denotes the speed here? The symbol V denotes the speed. So V speed V equal to distance divided by time taken. If we need distance means distance equal to speed into time taken will come, isn't it? Yes or no? So here distance, if we consider the distance, there are distance will be double, which means So it will move from transmitter to this object. It will move from this radar, this radar instrument to this object. It will take time 2 seconds, isn't it? Again, while it is returned back from this object to this radar, during that time also it will take time 2 seconds. Okay, so totally, what about the time? 4 seconds. It will take 4 seconds. Already told you number of times. In this case, especially the speed of the light, which is equal to the speed of the wave, that is c equal to 3 into 10 to the power of 8 meter per second. But that is general. The symbol c denotes the speed of the light. But in this case, we are which symbol denotes the what is the speed of that wave? V. So speed of the wave v equal to distance divided by time taken. So what is our aim? Our aim is to find out what is that? The distance between this radar to this object. Okay, if you wanted to find out means we can easily find out from this formula. Okay, so that is what d equal to v into t will come. V is nothing but speed of the wave and t is nothing but time taken. Okay, so now if you substitute that known values within this formula, automatically we can get or we can find out the distance between this what is the radar to this object. So before find out that, one more thing you should keep it in your mind, dear students. So here we should consider there are two distance. So what are the two distance? The first distance is the transmitter transmit the waves from this radar to this object. That is one distance. So after the waves strike on this object, again it is returned back. So that is another distance. So while it is returned back, the waves accept that signal. So there are two distance. So that's why what should we do here? So distance we should be double. Okay, distance we should be double. So now this known already we know that the value of speed, the value of time. So take the values, substitute within the formula. Automatically we can get the answer or find the distance between this radar to this object. Okay. So 2d equal to the distance of which means the speed of this wave 3 into 10 to the power of 8 meter per second. Here need not mention the unit. Into time, what will we get here? 4 will come. Okay. So 2d equal to, so 4 3s are 12 into 10 to the power of 8 will come. So we need a d distance. We should, our aim is to find out the distance. So keep distance here. So 12 into 10 to the power of 8. Okay. So what is that? If these two come from left hand side to right hand side, it is the denominator. Okay. What is the 2 will come. So if we cancel this, what will we get here? 6. So d equal to 6 into 10 to the power of 8. The unit of distance meter. Okay. So like this only, dear students, we can find out what is the distance between this radar to this object. Especially what is the use of this radar method? We can easily find out very what is that nearest distance from the earth to especially aeroplane or what is that planet like Mars. Automatically we can understand using this formula. Okay, this is the introduction. What is the explanation about the what is this radar method? So next we are going to discuss numerical problem. Okay, dear students. Now I am going to. Yeah, that is I don't know, sir. Okay, dear students, note down. Take one note and pen. So, what is it? Now we are going to solve the numerical problem. So, this is very, very important sum. We should, what is that? Note down properly. After reopen the school, definitely we will check one time. If you will not do means, we will say take severe action. Be careful. So, come to listen. Example 1.2. The question begin with the moon substance, an angle of 1 degree 55 minutes. This symbol indicates the minutes. At the baseline, equal to the diameter of the earth. Equal to the diameter of the earth. What is the distance of the moon? What is the distance of the moon from the earth? From the earth. So radius of the earth also they are given in your question. It's Google search. Radius of the earth. Radius of the earth. Radius of the earth is 6.4 into 10 to the power of 6 meter. So this is the radius of the earth. When the book itself they are given. Okay. So now we should read the question. So before solve the problem, we should read clearly the question 2 or more than 2 times. Why? Because then only we are able to gather the data. Then after, based on the data, we can select the formulas. And we should draw the diagram according by this question for our convenience, for our understanding. That's also very, very important. So let us start to read this question. The moon substance an angle of 1 degree 55 minutes at the base line to the equal diameter of the earth. So dear students, here we should consider or we call the 2 points. One is the, what is that? Moon substance and angle and the diameter of the earth. So let us assume this is the earth. What is this? Earth. Let us assume this is earth. And this is the moon and this is earth. The diameter of the earth, in the radius of the earth, in your book itself, they are given 6.4 10 to the power of 6 meter. So this is the diameter of the earth. Yes, sir. Okay, sir. Okay. This is the center of the earth. Okay, so this is the radius of the earth. The value of radius of the earth is 6.4 into. Okay, sir. Okay. This is the center of the earth, and this is the radius of the earth. The value of radius of the earth 6.4 into 10 to the power of 6 meter. So now already we have discussed in the parallax method. So if you wanna see, there are two things. So one is what is this moon is substance and angle 1 degree 55 minutes. This moon makes the angle with this earth angle, let us say theta. This is what parallax angle. The value of angle is 1 degree 55 minutes. Okay. So diameter of the earth. See, this is the baseline. Diameter of the earth is nothing but this is the baseline of the earth. Okay. So what is the distance of the moon from the earth? So distance of the moon from the earth is nothing but, yes, students, this is said to be distance of the moon from the earth. Now what is our aim? Our aim is to find the distance from the moon, earth to moon. If you want to find out means, we should select the formula. So what is the necessary formula here? Parallax angle formula. So what is the formula? X equal to B divided by theta. Theta is nothing but angle. B is nothing but base or diameter of the earth, and X is nothing but the distance between, let's say this is A, B. The distance between A to M or B to M. Okay. So now we should collect the data. So what are the given values here? Given data, theta given 1 degree 55 minutes. This one, see, always we should represent this theta in radian. Okay, in radian. So if you want to be represent means we can move step by step. Why? Because so this is given in the degree and also minute. So if you want to be convert means first this degree we should convert to the minute. Why? Because the nearest value of this degree what they are given to the minute. So that's why we should change. Okay. So 1 degree equal to 60 minutes. Okay. So now see these values we should add with this minute. So already here 55 minutes is there. So 1 degree instead of degree we should substitute this 60 minutes. What will we get here? Theta equal to 160 plus 55, 115 minutes. So this minutes we should convert to the second. Okay, we should convert to the second. So if you want to be convert to second minutes, especially 1 minute equal to 60 seconds. This two line indicate the second. So the apostrophe 1 line indicates the minute. Okay. So if you want to be convert this 150 minutes to second means we should multiple this minute with the what is that? This second. What is that? 1 minute equal to how many seconds? The second we should convert. So here theta equal to 115 into 1 minute equal to 60 seconds. So that 60 seconds we should what is that? Multiple with this 150 minutes. So now it is converted to second. Okay. So this second, if you want to convert to the radian means, what should we do? We should know 1 second equal to how many radian. So 1 second equal to 4.85 into 10 to the power of minus 6 rad, which means radian. 10 to the power of minus 6 rad. So we should multiple these values also with this. So theta equal to 115. 690. Okay. No, sir. For our convenience, finally, sir, for our convenience, we can substitute. Go to 690. Yes, sir. No, sir. We need sir for getting the simple getting answer. 115 into 60 seconds into 4.85 into 10 to the power of minus 6. So if you simplify these values, well, the scale. Which one, sir? The scale. It's not moving, sir. It's okay. Sir. Sir, one, sir. This is a first class. If you simplify this, we can get what is that? 3.34 into 10 to the power of minus 2 rad. Now we found what is it? The value of theta. Now our next aim is to find out the distance from the center of the earth to moon. Already told you. I written the formula also here. X equal to b divided by theta. Theta is nothing but angle. B is nothing but base or diameter of this. What is that? Earth and what is that? This is the distance between this A to M or B to M. Okay. So now take write down here formula. Write down here formula. X equal to b divided by theta. Okay. So x is nothing but the distance between center of the earth to moon. So x equal to, now the value of theta we know that. Okay, the value of theta we know that. The one more thing is this is the base or diameter of the earth. Radius they are given, but diameter we should convert from the radius. Isn't it? Yes or no? That's very, very important. The value of radius already we know that r equal to 6.4 into 10 to the power of 6 meter. So if you double this radius, we can get the diameter of the earth. Okay. So which symbol denotes the, especially for convenient for this diagram, which symbol denotes the radius here? The symbol B denotes the radius. Okay. So instead of R, we can substitute B. B. So 2B will come. Base or diameter of the earth. So 2B is nothing but 2 into 6.4 into 10 to the power of 6 meter. If you multiple this 2 with the 6.4, what will we get here? Okay, 12.8 into 10 to the power of 6 meter. Take this is the value of B. Take this value, substitute in the formula. We know that already value of theta and value of B also. What is the value of B? 12.8 into 10 to the power of 6 divided by the value of theta also. Already we know that 3.34 into 10 to the power of minus 2 radian will come. So if you simplify these values, we can get, or if you have any doubt means, so what is the for capital this? If you multiple in the numerator and denominator 10, so if you simplify, automatically we can get the value 3.83 into 10 to the power of this minus 2, 10 to the power of minus 2. If this goes from denominator to numerator, what will we get? Already 10 to the power of 6 is there. If this minus 2 goes from denominator to numerator, it will be converted from minus 2 plus, so 10 to the 6 plus 2, 10 to the power of 8. 10 to the power of 8 distance meter. So this is the final or distance from the center of the earth to moon. So like this only we should, what is that? Find out, dear students. This is the very important sum, and sometimes they may ask what is that in your exam also. You should note down properly. Okay. So next we are going to discuss another sum. Sir. Oh. So next we are going to discuss about the numerical problem, example 1.3. Example 1.3. The question begins with a radar signal. Yeah, I know that I have. A radar signal is beamed towards here. Beamed towards a planet and its echo. Planets and its echo is received 7 minutes. Received 7 minutes later. If the distance between the planets between the distance between the planet and the earth is 6.3 into 10 to the power of 10 meter. 6.3 into 10 to the power of 10 meter. Calculate the speed of the signal. Calculate the speed of the signal. Conclusion, dear students. Already told you a number of times before going to start the solution. We should read 2 times or more than 2 times this question carefully. Let us read this question. A radar signal is beamed. Beamed is nothing but the waves moving from one place to another place. 2 waves or more than 2 waves we call as a beam. That is here they are given in the past tense. Beamed. A radar signal. Already told you. We should draw the diagram for our content to understand this question. Okay. So this is the. Let us. This is the radar. Okay. Beamed towards the planet. This is the planet. So the beam, the waves are start to move from this radar to this planet, like this. Already told you there are 2 components. One is the transmitter, another is the receiver. The working of transmitter is transmit the electromagnetic waves, and the working of the receiver is accept the that signal waves. Okay. Radar signal is beamed towards the planet and its echo is received 7 minutes later. So in previous case, we have discussed 2 seconds. The time taken to move from one place to another place, 2 seconds. But here, the echo is nothing but the repetition of sound. Okay. So while it is moving from this transmitter to this planet, after this wave striking on this planet, it will be bouncing back. I told you, for example, if you throw it any ball towards the wall, so after the ball is striking on the wall, again it is bouncing back, isn't it? Yes or no? The same principle we are applying here also. So it is after this wave is striking on this planet, again return back. So this receiver is accept that signal. Okay. So this arrow mark denotes the direction of this wave. Okay. So this is, we can say, echo, the repetition of sound, the return back that sound waves we call as a echo. So especially time taken to complete this echo, 7 minutes. If the distance between the planet and the earth is okay, so where we are placing this radar in earth, okay, so it is inside the earth. Okay, so the distance between the earth to planet, how much? 6.3 into 10 to the power of 10 meter. 6.3 into 10 to the power of 10 meter. What is our next aim? Our next aim is to find out calculate the speed of the signal. Okay, we know the formula. Speed equal to distance divided by time taken. Here, our aim is to find out what is that? Speed. Okay, what is that? Speed. So this formula itself, you can no need to alter here. So V equal to the value of, or otherwise, if you feel very difficult, means take these values, write down here. T equal to seconds. So 1 minute equal to 60 seconds. So T equal to 7 into 60 seconds. So if you multiply these values, what will we get here? What is that? 420 second will come, isn't it? Yes or no? So take these known values, substitute within the formula. Let us see what will we get here. Okay. So the distance of the signal also we know that, but this is a 2 distance, isn't it? Double. Sorry, 4. 4. Okay, 420 second. 426. So here the distance will be double. So what will we get here? So especially 2d will come. 2d divided by t. So 2 okay 2 into distance 6.3 into 10 to the power of 10 divided by the time 420 will come. So V equal to, if we cancel this, 2 to the 4, 1, 0 will come, isn't it? So 6.3 into 10 to the power of 10 divided by 2, 10 will come. Okay. So if you simplify these values, or if you feel any difficult to simplify this, so here point is there. So that's why we should multiply in the numerator, the denominator, what is the 10 with the 10. So finally, you can get V equal to 3 into 10 to the power of 8 meter per second. So this is nothing but the speed of the signal or electromagnetic waves, which is equal to the speed of the light. Okay, so almost, which means what is that now? Equal, like that we can take. So this is the, what is that? Explanation about the numerical problem. Okay, so if you have any query, already you know my number, so you can ask what is that through the WhatsApp group or make me call. Always I ready to clear out doubt. Okay, nice to see you. Nice to talk with you, dear students. Stay home, stay safe. Feedback. 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 Sorry, okay.
Okay, thank you, students. Take your lunch break and be back by 2 p.m. for your language class.